Hello, dear students. I am Mayur Limbachia. Welcomes you all on my YouTube channel. Dear students, in this video lecture, we will solve the example number 1.5 of Standard 12, chapter number 1. Dear students, the definition of example 1.5 is given on your screen. So let's read the definition first, and based on the given parameter, we will solve the problem. The definition states that consider three charges Q1, Q2, Q3, each equal to Q at the vertices of an equilateral triangle of side L. So what they have given us, so the given parameter is there are three charges Q1, Q2 and Q3 which is equal to Q, and these three charges are placed at the vertices of the triangle. This triangle is equilateral triangle having L side. Okay, so this is the three charges. Now what else they gave? What is the force on the charge capital Q with the same sign as Q placed at the centroid of the triangle as shown in figure 1.6? So they gave us that capital Q, which is equal to Q, is placed at the centroid of the triangle, and we have to find out the force on capital Q. We have to find out this force. Fine. So dear students, here in this case, if we have to find out the total force, net force on the capital Q, what we have to find out is we have to find out first the force between Q1 and Q, then Q2 and Q, and then Q3 and Q. So we have to find out the individual forces, and then we have to do the summation, and that summation will be done by superposition theorem. So with the help of the superposition theorem, we can solve this problem. So let's just find out first that the force F1 because of the charge Q1. Fine. So can I write like this? That force F1 because because of charge Q1. Q is small here, so Q1. So what we can write? F1 will be equation is K. Sorry, F is equal to K. F is equal to K Q1 Q2 divided by R square. This is our electrical force equation, or we can say Coulombian force. That is also the name of this force. So if we write this F1, then let me write this F1 as a magnitude, not as vector. Later on, we will convert that into the vector. Fine. So it will be easier for me to write that force into magnitude, and then later on we will give the direction to that force. Okay, so it will become vector. Now F1 K. So Q1, what is Q1? Q1 is Q, and capital Q is also Q. So Q square divided by, now the distance between capital Q and small q, it means this distance, and this distance is AO. Now this distance will also we have to find out. It will be BO, and this distance will be CO. So dear students, what we have to find out is we have to find out first AO, BO and CO. So we can substitute that AO, BO and CO here in this equation. For the Q1Q, the distance will be AO square. AO. Okay. So here my first task is to find out AO square, BO means AO, BO and CO. So to find out AO, BO and CO, can I use the trigonometry equation or trigonometry formulas? Yes, I can. How? So if you have a triangle, and if it is equilateral triangle, we know that the summation of all the angles of this triangle will be 180. So the individual angle will be 60 as well. Fine. So can we use this angle 60 and we can find the length of the maiden. This AD is the maiden of this equilateral triangle. So first we find out the maiden AD and then we will find out AO. Fine. So this is my strategy. Now to find out the maiden AO, dear students, what I can do is I will use this angle. Look at that. This angle, and this angle will be 60. So now we have a right angle triangle. Right angle triangle ABD. So in right angle triangle ABD, look at that again. Right angle triangle A, B, and D. So if I will use this right angle triangle ABD, and if I will apply a sine on this 60 angle, then I can easily find out the AD is maiden of the triangle. Now I can write that applying sine on right angle triangle ABD at 60. So can I write like this? Sine 60 is equal to sine will be opposite side divided by hypotenuse. So which one is the opposite side here in this case? Opposite side will be AD, which is maiden, and hypotenuse will be L, AB. So I can write opposite side, which is AD, maiden, and hypotenuse, which is AB. And AB is what? AB is L. So AD divided by L. Therefore, can I write AD is equal to L sine 60? Sine 60. Now sine 60 is what? Sine 60 is root 3 by 2. So therefore, AD is equal to L root 3 by 2. This is the equation number. Let me give this equation number 2. Fine. Now I have a maiden of this triangle. Now what I have to do is I have to find out AO. So when you look at the geography, or I can say the figure, the situation of the figure, here I can say this AO is 2/3 of maiden AD. AO is what? 2/3 of AD maiden. So with the help of this particular relation, can I use this, that from the figure the AO will be AO is equal to 2/3 of AD. Okay, because why? See, when you draw the maiden AD and this is your centroid of the triangle, then this distance is always 2/3 and this distance will be 1/3. Fine. So this is the always case in centroid of the triangle. If you don't remember, please write down that relationship. It will be helpful for you for the rest of the example when it will be the scenario. Okay. So now I can use the equation number 2 here. So substituting equation 2, can I write like this? AO is equal to 2/3 the value of AD. Value of AD is what? L root 3 by 2. So 2 will get cancelled. AO will become root 3 by 3 into L. Now what is root 3 by 3? Can I write like this? Root 3 by 3 is always equal to root 3. So here in this case, I can write now AO is equal to root 3 multiplied by L. So dear students, now we have a AO. So AO is equal to BO is equal to CO will be root 3L. So now we have a AO, BO and CO. So now we can find the force between Q1Q, Q2Q and Q3Q. Fine. So now I can substitute this value here in equation number 1. Substituting in equation, substituting value of AO, value of AO in equation 1. So dear students, can I write F1 is equal to KQ square divided by, now what is AO? AO is root 3L square. So this will be KQ square 3L square. Where? 3L square. Fine. So here in this case, dear student, the value will be, the value of the force will be AQ square divided by 3L square. Fine. Now, this is the force Q1 on capital Q. Can we write from the force F1? We can write the force because of Q2 on Q can be written as F2 is equal to KQ square BO square. What is the value of BO? Same. So KQ square divided by root 3L square. So it will be the same. KQ square 3L square. So look at that. These and these values are same. Why it is the same? Because look at that. All the charges are same here, as well as the Q is also the same. That's why the force is same between all of these three charges, pair of the charges. So dear students, now the same thing I can write for Q3, the force because of Q3 on Q. So F3 will be KQ square CO square is equal to KQ square, again root 3L square is equal to KQ square 3L square. So we can write that F1 is equal to F2 is equal to F3 is equal to F. Correct? Fine. So now, dear students, this is the force, magnitude of the force because of Q1 on Q, Q2 on Q and Q3. Now what we can write here, we have to find out the total force. How can we calculate the total force? Dear student, to calculate the total force, now what I can use is, use the figure. Look at that. The F1 force is along at AD direction. Along at AD direction. The F2 force is along on BO direction. And the FC force is along CO direction. So can I write that F1, look at here, F1, now F1 will be in AD direction. That same here I can write, this is F2 na, BO direction. And this is I can write CO direction. Okay. So now I can write this magnitude as a vector. Right. So now with the help of these three vector from the figure, if I will combine these vectors, look at here on figure. if I will combine these three forces by applying the vector sum of two vectors, it means there are two method to do the summation of vector. First, triangle method, and second, parallelogram method. So here, dear students, if I will use parallelogram method between this f3 and f2. So suppose f3 and f2 will be used like this. This is the parallelogram method. Then we will have the resultant vector like this. And our f1 is here on downward side. This is the resultant of what? Resultant of f2 plus f3, f2 plus f3. So with the help of this r, now I can find the total force. So what should be my first step? My first step should be I have to use a parallelogram method between f2 and f3. Fine. So let's use, as per the figure, figure force figure using parallelogram method on f2 and f3, which will be like this. Suppose this is point O, your force is like that. This is f2, this is f3. So what we can do is we can draw a parallel vector here. We can draw parallel vector here, and then we will connect these. This will be our resultant vector, which will be the sum of these two vectors. Fine. But for that, we have to find out this angle. This theta angle we have to find out first. So what will be the theta angle? Because the equation we use will be r is equal to under root of a square plus b square plus 2ab cos theta. That's why I have to find out the theta first. Now how can I find out the theta? The theta can be find out from the figure itself. So look at that. Suppose this angle is let me take a total angle. Suppose this is the angle 60. Fine. And this angle will be 60 as well. What will be this angle? So if I will draw a line like this, you can see it is a quadrilateral side. Quadrilateral side having the total angle 360. The summation of all angles of this quadrilateral shape will be 360. We already know that this is 60 angle. This will be 90 angle. This will be 90 angle. So what will be the angle of this? So 90 plus 90 plus 60. So 180 plus 60. So 180 plus 60 will be, let me write like this, 360 minus, fine, 360 minus, why 360 minus? Because summation of all this angle, let me give this angle as a x. So the x will be, or 360 will be x plus 90 plus 90 plus 60. If I will do the summation of all the angles, it will become 360. Fine. So x will become, x is equal to 360 minus 90 minus 90 minus 60. So if you do this, you will have a 120. Fine. So this will be 120. So I can say the angle will be, here in this case, 120. 120. So if angle is 120, Now I can use this formula R, which is the resultant of these two, under root of f1 square plus f2 square. Now look at that. We have considered that f1 is equal to f2 is equal to f. Yeah. f1 is equal to f2 is equal to f. So I will write f instead of f1, f2. Fine. So f square plus f square plus 2ff cos 120. Now what will be the result of cos 120? Minus 1 by 2. So r is equal to under root of f square. Can we write like this 2f square? Yes, we can, plus 2f square minus 1 by 2. So this will become 2f square minus, the sign will be go ahead of this step. 2 gets cancelled and it will be minus f square. So now we can write under root of f square, it will be f. So dear students, your resultant vector will be f, and this is the value magnitude. But if we have to write down the direction of this particular vector, then I can write f, and the result will be means the direction will be on OA side. No, not the OA side, DA side. Yeah, DA side. Fine. So DA side, DA. Fine. Now, dear students, we have a resultant of f1 plus f2. Now we have to do the summation with f1 itself. So if I will draw the same f1 here on this particular point, this is my f1. So look at that. This r is at DA direction, in DA direction, EA direction. And this is in AD direction. So both are equal, but in opposite direction. Why both are equal? Because both are having the magnitude f. It means the same value of f. Fine. So can we write f q or f net? Net means total. Will be r plus r plus r plus f. Okay. So how can I do the summation of r and f1? R and f1 with the help of the same method. But here in this case, the angle will be 180. So now applying parallelogram method on r and f1. So can I write like this, dear students, that the total force or net force, the magnitude of the net force will become r square plus f1 square plus 2 r1 f1 cos theta. But r is also f1 is also f. Look at that. f1 is what? f1 is also f. Fine. So therefore we can write f net or fq, whatever you can write. This will become f square plus 2ff cos 180, because the direction, the angle between these two forces are 180, and we know that what is the value of 180? Value of 180 will be minus 1. So under root of 2f square plus 2f square minus 1. So therefore f net is equal to under root of 2f square minus 2f square minus 2f square. That's why it will be 0. So, dear students, the total force on capital Q, total force on capital Q will be 0. So this is the answer of this example. Dear students, this method is very simple. You have to use a parallelogram method to find out the resultant force on the capital Q. So I hope you understand this problem. If you have a doubt regarding this, you can write me on a comment. I'll surely reply you. If you like, please do subscribe the channel and share these videos to your friends, to your classmates. And if you like it, please hit the like button. Now we will meet on the next video. Till be safe, do focus, and do your studies.